Thank you. For those of you watching at home, hi. This is an unusual change of schedule. We're going to be doing the test on Monday instead of today. Today is Friday, January 27th. Ta-da! And there's so many people gone, bless you, and so many people who haven't gone. And the silly video did not post for whatever technical glitch reason, which I'm going to go in and kill the internet. And put a new improved internet out that won't glitch. But for now, I guess we're going to run through practice problems. What I'd like you to do is at least tell me which problem you'd like to go through and what type, and I can make up a new version of that. And let me grab a copy of this. All right. So, tell me what type of problem would you like to work? Here.
Can we do one of the related rate problems?
Related rate problems. Okay. Now, I will give you an option. There are two possible shapes we could use. It's very likely it's going to be a cone. It's possible it would be a sphere. So, I'll do a cone first, but you tell me, would you rather the cone be, let's try and talk this in English. Would you rather the cone be filling up or leaking out? Filling up? Okay. So here's the setup. You have a cone. You know, it's not that hard to spell cone. There's a cone that is, I'll just draw it for you. Where the top of the cone has a diameter of 20 millimeters, and the height is 40 millimeters. Okay? And it's somewhere down here, it has some water in it. It's being filled at a certain rate. You don't know the certain rate. But you do know that the water level is rising 5 millimeters per second. Okay. The question is, how fast is the water coming into the cone when the water level reaches 20 millimeters. So there's the whole setup. You've got a cone, those are the dimensions of the cone. And there's water inside it, not all the way up to the top. How fast is the water coming into the cone when the water level reaches 20 millimeters? First things first, I will just cut you loose and somebody tell me how to start this problem. Raise your hand if you know. Go.
Well, you know that you have dH over dt.
Correct. The water level is rising. Another name for the water level is height. So this is dH over dt, the change in height over the change in time, and it's equal to what?
It's equal to 5.
5, positive or negative? Positive. Why positive?
Because it's increasing.
Right. The height is increasing. If it were leaking out, this would be -5. You'd have to manually change it to negative. All right? Nick, what else can you tell me?
Do we need to have dV over dt?
How fast is the water coming is in fact change in volume over change in time. That's correct. So that's what our answer is. That's what we want our answer to be. So how do you set the problem up? Randy, help me out.
Okay, so you need to find the next fraction, is that what we're
Correct. So what's the fractions we have so far?
We have dH over dt.
Okay, so I got dH over dt, and then what should I write?
Is dv over dh. Wait, what do you mean?
Maybe. So in other words, there's an equation I have to write out. So first
Yeah.
fraction, and then
Times
times, and then mystery fraction
Yeah.
equals what?
dv over dt.
Exactly. And then what's the mystery fraction?
dv over dh.
Right, how do you know?
Because the dh's have to cancel and the dv's on top.
Correct. The dv has to be on top, dh is canceled. Good. Do we have any of those so far?
Yeah, we have dh over dt.
Right, and that's fine.
Yeah.
I do not have this yet, and this will give us our answer. So question, how do you get dv over dh? Becca, take over.
You're gonna use the volume.
Volume formula. What is the volume formula?
1/3 pi r squared h.
1/3 pi r squared h, correct. Is there anything wrong with using that at this point?
You need a third of the r.
Right, I want to get rid of the r, because I want dh's and I want dv's, but I do not want drs contaminating my problem. Is there any possible way to cure that problem? Blaze, take over. I want to get rid of that r. Is there any legal way to do that? Find it in terms of h. So is there anything up here that would tell us any equation at all? Yeah, so we've got, right now we've got what two things? Like what two dimensions have they given us? The height and the diameter. Very good. So height and diameter, how do they compare?
So it should be, the diameter is 1/2 the height.
Diameter is 1/2 the height, or if you want to go backwards, the height is what?
2 times the diameter.
2 times the diameter. So it's up to you. Now, there is a catch. Nowhere in here are they talking about diameter. How do you get out of that problem? Nick? Think geometry.
Which means 2r.
Yeah, what am I saying? The diameter, I was trying to say geometry and diameter at the same time, did not work. The diameter is 2 radii. So you could say that the height is 4 radii. Does that make sense? And 4 times the radius. And if you want to do it the other way around, 2r is equal to 1/2 h. Can you get r by itself? Go ahead. Yeah.
So can you say it one more time?
Get r by itself.
Divide that through
Yeah, so what do you get? What's half of a half h?
h.
That's twice.
1/4.
1/4. No, whisper answers, doesn't help. So radius is 1/4 the height. That will help. Nate, finish that off for me. Simplify. I would not take the derivative in this form. It's a disaster. Go ahead. What do you do first for simplifying?
Oh, you do the square. The
Okay.
exponent.
Keep in mind, he's not going to be whispering hints into your ear on the test.
Yeah.
So you gotta get this in your own. Yeah, PEMDAS, so please excuse me, dear Aunt Sally. Do the exponents first, do it.
It's gonna be 1/8. Oh, no. 16.
Say again.
1/16.
1/16,
H squared.
good. Keep on simplifying,
And you would distribute. the-
okay? What do you get? Sam, take over.
Yeah. Right. B1. 38.
16 times 3,
40.
pi
H cubed, pi H cubed.
pi h cubed, correct. Now, what do you do with that? What's the point of getting that? Awesome.
So then with that, you can take the derivative.
Take the derivative, let's try it.
So
Do
you
it.
dv equals, so you'll have 3 over 48 for the 1 over 16,
Right?
pi h squared dh.
100%, that's a mess. Hang on a second, I'm just gonna do 3 over 48. I'll rewrite it in a second. Then pi h squared and then what?
dh.
dh, good. So I'm gonna rewrite this. dv equals 1 over 16 pi h squared dh. What fraction are we trying to get again?
dv over dh.
How do you do that?
Divide by dh.
Right, divide both sides by dh. It turns out you don't have to do any arithmetic, it's just done. So put that here, 1 over 16 pi r h, what the heck am I doing? Pi h squared. Did they give us a value of height to play with? Good.
Which one do you know?
Yeah, they said when the water level, which is another word for height, is 20. Plug that in. So 5 times 1 over 16 pi times 20 squared. Calculate for me, Nate, go.
So you're gonna square 20.
Okay,
So
400.
100. Then you're gonna distribute the.
Now distribute, don't do it to both, be careful, because it's not plus. But 5 times this mess. What's 5 times 400 now?
2,000.
Yeah, so 2,000 over what? Well, 2,000
Pi.
pi over 16. That's the only thing in the bottom. Does that reduce?
Yeah.
Do it. Do it piece by piece.
Okay, you just take them in half.
Okay.
Times
So 1,000 pi over
8.
8. Keep going.
And then 500 over 4.
Okay.
250 over 2.
50 over 2.
And then 125.
That's your answer. But 125 pi what? What units?
Millimeters.
What are you looking at? I think you're looking in the right spot, but where do you look to find the units? Like, what's the answers? But what fraction is the answer? Which of those?
Volume over time.
Yeah, volume over time. So what's the unit for volume?
Millimeters.
Millimeters is length. Say again?
I don't know.
Okay, so
Millimeters cubed.
millimeters cubed over what
Second.
per second? That's your answer. Does that make sense? Yeah, question.
Is it possible we could go over all the different, like, this time we use diameter instead of radius?
Okay.
Could we just go over all the different things that we might need to know from geometry?
Oh,
Applicable for this? Because
okay.
it changes every time we do it.
Right. Now, there are loads of different creative ways to do it. They might have said when the circumference is going, that's cruel, but it's possible. I've run into problems like that, where you say, how fast is the circumference changing when the water level is changing? You're like, really? But it's possible. The only ones you're going to need to know are a radius versus a diameter. A diameter is equal to 2 radii. That's one. You'll need to know the area of a circle, which is pi r squared. I seriously doubt you'll have to worry about circumference. You'll need to know the volume of a cone. I think that's kind of it. Those are the only like twists and turns that I might get. Okay, so no problem. So the only time we worry about like diameter and radius and things like that is when we're trying to do that substitution to get rid of that extra variable. something in this geometry shape will give us an equation. In this case, it was r equals 1/4 h. So the radius is 1/4 as big as the height. Make sense? Alrighty, questions on that before we go on? Alright, did you want another one of those or a different one? Hand raised and I will obey you. Go.
0 minimum, maximum.
Max min, okay. Does everybody count on this part? Anybody still ready? Okay, speak now, forever hold your equation. Okay. So by max min, like problem number what?
Like 6 or 7.
Problem number 6 or 7? Okay. Got it. Okay. Find all points of relative max and min. And I will, in order to be merciful, not give you any things with x in the basement. Those are possible, but they're time consuming and probably too long for the test. So let me try the following. Example. Y is equal to 2x cubed minus, let's see, 8x. And I would like to find all maxes and mins. Make sure you include both. Something comes something. Where do you start? Go.
The derivative.
Take the derivative, definitely. Y prime is what?
6x squared minus 8.
All right. Now what? Please, take over.
7 over 0.
Right. Why?
So,
Right. Because every time you hit a smooth max or min, what's the derivative there?
0.
0. So if you set the derivative equal to 0, you'll flush all those problems out, and you'll be able to see them. Do it.
So add 8.
Okay, add 8, so 6x squared equals 8.
Divide by 6.
Okay. X squared equals 8 over 6, better known as 4 over 3. Okay. Square roots. So x equals, I'm going to write these separately. Radical 4/3, negative radical 4/3. Please do not make the inside negative. That's not what square roots do. Do these reduce at all? There's a little bit of reducing you could do. Yeah, the radical 4 is what?
2.
Yeah, 2. Feel free to leave the radical in the basement. I don't really care about that. But this is considered a good reduction. Now the question, there are two more things I need to know. 2/3 comma what? And is that a max or min? Tell me how you do that. So you're in the middle of a test. Tell me how you get that. Awesome, go.
Well, we know that since it's a positive cubic. So
Ah.
You start up and go down.
Degree of 3, it's going to go up, down, up. Which means what? What has to come first?
Max.
The maximum has to come first. When you're going from left to right. Which one is furthest left?
The negative.
The negative. This is the one that goes here. This is the positive value of x, which must be here, and that must be the minimum. So this is a maximum, this is a minimum. Again, your pre-calculus is going to come in very handy here. There is a calculus way to do that, but I'll cover that more next chapter. For now, a maximum should be at negative 2 over radical 3, comma what? Nick, take over. Negative 2 over radical 3, comma what?
Oh,
Actually, I called Nick. You're up there.
do we have to pull it down?
Yes, indeed. Do it.
2.
2 times, and by the way, you can leave it like this if you want.
Yeah, we'll do that.
It's all totally up to you. Times radical 4/3 cubed minus 8 times radical 4/3. Go for it. What happens here? I wasn't promising that leaving it that way would be easier. It might be.
Is it 4/3
4/3 times radical 4/3 times radical 4/3.
So, four,
This is, believe it or not, this is first year algebra.
okay.
Not meaning to make you feel bad, but quick question. What's radical 7 times radical 7 times radical 7? Go. These become 7.
Okay,
Do that.
so then 4/3.
Yes.
Radical 4/3.
4/3 times radical 4/3. Good. 2 times 4/3. And then minus, how do you do this?
So would it just be, so 8/1,
801 times.
radical 4/3?
Right. Now, simplify it. This thing turns into what?
8/3.
8/3. And simplify this again.
Just, for a radical, oh, 2 over radical 3.
Okay? Minus what? 2
8
times.
2 over radical 3.
Okay? Go for it.
16 over 3 radical 3
Okay?
minus 16 over radical 3.
Get a common denominator. Go.
5/3.
Yeah, this is missing a 3, as long as you do it to both sides. So what does that talk about? 16 over 3 radical 3 minus what?
48.
48 over 3 radical 3, which is?
It's gonna be negative, 32 over 3.
That's it.
That's super easy.
That's your maximum.
So excited.
Did I just take a little drip of sarcasm in
It
Yeah,
just-
go.
Is there any, like, calculus way to figure that out? So you don't have to mess with, like, all the radicals?
there? Calculus does not immunize you from radicals, my friend. Short answer is no, sorry. The only way to find a height is to plug it into the original equation. Yeah, good.
Whenever you have the maximum, is the other one always gonna be like just the opposite height?
Oh, the question is, if you have something like this, and you got, like this is a height of negative radical 32 over 3 radical 3. So basically what you had, this is negative square root of 4/3. It's gonna kind of go like this. So both the max and the min are below 0. They're both negative. The question is this a mirror image of this? Not always, unfortunately. So, find the other one. Oh, please. Come on.
Plug it in again.
Yes, exactly. Little piece of advice. It actually is a little bit easier if you plug it in the simplified form. Watch that. I'll do it in turbo speed just in case you need a breather. 2 over radical 3 cubed minus 8 times 2 over radical 3. This becomes 2 times 8 over 3 radical 3. Everybody see how I got the bottom? Radical 3 times radical 3 times radical 3. I erased it, but it's 3 radical 3. Minus 16 over radical 3. Now, this becomes this. So 8 minus 48 is 40, so 2 times negative 40 over 3 radical 3. Then put this over 1. This is negative 80 over 3 radical 3, and that's your other height. So the minimum is positive 2 over radical 3, negative 80 over 3 radical 3. So sometimes the maxes and mins are nice, sometimes they're a little annoying. I would would definitely put this in the annoying category. Whenever you have radicals in your answer and you have to plug them in, usually it's aggravating. There's really not, it builds character. There's not much a way around that. But they'll probably be a little bit more tame on the test. They probably won't take that long. But be prepared, there might be a radical or two floating around in your life. So, next. Any other type of problem you want to see? We got a related rate problem. We can revisit that if you want. How's everybody doing on Newton's method? Do you want one of those?
Yes, please.
Okay. This. So Newton's method, let me just pick one off the top of my head. Alpha max, or they have y equals, I guess. Same difference. I'll do y equals. Let's try x cubed minus x minus 5. I would like you to find all real roots to 4 decimal places. Grab your calculator, you'll need them. Oh, that's right, my batteries are dead. Hang on. I did buy new batteries. Double A. There you go. Okay, so where do you even begin? How do you start this thing? Go.
Do you take the derivative?
You definitely do,
Let's go.
but, okay.
Okay, we do
Ah.
both at the same time.
Where do you put the original function?
In the graph,
y1, excellent. In what screen?
y equals.
Y equals screen, correct. Go to the y equals screen, I'm just throwing away my batteries because they're dead. By the way, make sure you have your battery properly charged for tomorrow. Just saying. Not tomorrow, Monday. Yeah, don't come in tomorrow. I'm not either, if that makes you feel any better. I'm probably gonna be shoveling snow. Yeah, well.
Yeah, I think it's today should not snow day.
Oh, geez, seriously?
The roads will-
There were like 5 millimeters of snow.
That was Josh. Yeah, Josh died.
What do you say? Okay, got this. What in the world? Anyway,
Oh yeah, that's right. What happens when you
sorry about the delay, hang on a second.
world park?
This should be working. And, oh, that's awkward. That thing is dead, but okay, we'll work on it. X cubed minus x minus 5. So y1, I'll see how much I can do on my own, is x cubed minus x minus 5. What's y2? Go.
3x squared minus x, I mean
Minus 1, correct. Go ahead and enter those in if you haven't already. Now, which of these do we really want to graph? Go. The y1.
That's right.
How do you take off the y2 so it doesn't get in your way? Click on the equal sign. Go to the y equals screen and click on the equals. That will turn off. If the equal sign is dark, that means it'll graph. If the equal sign is not dark, that means it will not graph. Okay, less sound effects, y'all. And let's see what we do. Please let this work. Oh, there we go. RAM cleared. whatever. It's for the, anyway,
Yeah.
I have it stored somewhere. X cubed minus x minus 5. Oh, that stinks. So 3x squared minus 1. Okay. So take off the y2 graph, and then how many real roots does this thing seem to have? Go. How do you know?
Because it only crosses the x-axis once.
Right, it only crosses the x-axis once. Roughly where? Roughly at 2. Let's, how would you get a better zoom in? What zoom setting do you use? Zoom decimal is a good zoom in. Is it exactly 2?
It is.
It is not.
Dang it.
By the way, a way to check, plug in a 2 and see if you actually get an answer of 0. This is 8, 7, 6, 5, 4, 3, 2, 1. It is not. Close but no cigar. So tell me what to do.
Second calc 0.
Yeah.
So you take your guess of 1.9.
Okay, that sounds good. So I'll say x0 is 1.9. What do you do with it?
So in your calculator, you put 1.9, tap enter.
Okay, so I back up for a second. Are you doing the long way, which is compute, compute, compute? Are you doing the medium way, which is store into A, or are you doing the short method, which is using ANS?
ANS.
Okay. Again, I'm posting the video, which is about ANS, but if anybody didn't get this, here's the formula for Newton's method. X n plus 1 is equal to x of n minus f of x of n over f prime of x of n. So basically this means that if you want to get x1, which is the next guess, you start with x0 and subtract the original function's x0 divided by the derivative's x0. That should work. If you have, the speedy way to do this is to take your first guess and just hit enter. Then you type this, ANS minus y1 ANS divided by y2 parentheses ANS. It looks very cryptic, but that is the fastest way to get this. So 1.9, hit enter. It'll spit 1.9 back at you. Then call up ANS, you'll need to know where to find it, minus, did I wipe out? Okay, good. Type 1.9, or whatever number you're guessing, and hit enter, nothing but enter. That'll store 1.9 in temporary memory. Then you type this formula. You'll have to remember how to call up y1, and then parentheses ANS, then divided by y2, call that up, and then parentheses ANS. Whoops. Right. As soon as you're ready, hit enter. What did you get for x1, anybody? The first cycle through. Anybody got one? Give me the first 4 decimal places.
1.9041.
Yeah. 1.9041, blah, blah, blah. Technically it's 1.9042. How do you get the next one? If you go,
Yeah, if you did ANS, you just tap enter.
if you have this formula in, all you have to do is hit enter again. 1.90416. X3, just hit enter again. 1.90416. Interestingly enough, this is 4170905. This is 914160859, and this is 0859. This will show you how fast Newton's method got to the right answer. Between the second and third cycles, the accuracy is off screen. It's accurate to 10 decimal places already after 2 cycles. So the closer you get to the real root, the faster it'll get to the final answer. But even if it's anywhere near 1.9, it should be decent. Don't go off and do like x equals 5. Like then, yeah, it's at your own risk. Does that make sense, Abra? Any other questions on Newton's method? You want to try another one?
Yeah, well,
One more? Okay. Tell you what. You asked for possible variations. I'll give you possible variation.
Damn slow.
Y equals cosine of x. And I want to limit it
we should be fine. Is there any answer?
from 0 to 3. All right, all yours. I want to find all the roots. All yours. Tell me what to do. Wrong. It's a great way to get an F on a test. Just saying. I'm sorry?
The derivative is
Derivative is what?
negative sine.
Excellent. The derivative of cosine is negative sine. We knew that from first semester. So what do you do? Let me know what mode we should be in. When you're doing trig and you're graphing, it should be in radian mode. That's something we learned in pre-calc. When you're graphing trig, always put it in radian mode. Always, always, always. So, now what? Don't just sit there like a deer in the headlights. Do something. No, my old high school math teacher used to say, if you don't know what to do, do something. Once you're moving, you can usually, yeah, go. Yeah, plug it in the calculator. Go to the y1 and put cosine of x. And in y2, by the way, make sure you don't put subtract sine of x, make sure it's negative. Negative sine of x. Okay? So, what now? I got them in. What mode? How do you switch the mode? Go to mode. Yeah, the third row, use choice of radians versus degrees. Make sure radian is darkened. Otherwise, you'll get the wrong answer. All right, now what? Command me. Yeah. Go to your graph. I just hit the graph. By the way, if you don't change the zoom setting, it'll stay the one it was before. I have it on zoom decimal, which actually isn't too bad. I've got two different graphs though. Yeah, bless you. Go to Y2 and turn off the graph, and then graph again. You'll notice cosine is behaving itself. It starts at the max and goes down. So, does it have any roots between 0 and 3? Where? By the way, does anybody know where that is? Yeah.
1.57.
Maybe? Does anybody know where it is exactly from pre-calc? Pi is 3.14.
4/3 pi.
Yeah, that you're thinking of the volume of a sphere. So don't get there. What? All right. You got it. That's pi over 2. Now pretend you don't know that. Let Newton's method take it. Tell me what's to guess. 1.6. Sounds good.
That's why I stacked that.
First guess is 1.6. Get out of the graph. Tell me what to type. I'm on the main screen and I've hit clear, so there's no junk there. 1.6 and enter. All right. Now what? A and S. And fluffernutters. Hang on. Okay. A and S, then minus vars, y vars, function y1, parentheses, ands. Okay, this is getting a little weird. And then variables, y2, parentheses, a and s. Because you can actually do ANS immediately after, and it'll multiply instead of plug in, which is bad. So I just typed in. Your first answer is, somebody read it up? Yeah, 1.5707-88022. Hit enter again. X2, 1.5707-96327. X3, it's identical. In other words, it got so accurate so fast that the third cycle didn't even gain us any visible accuracy. Where you would put X is approximately 1.5708. Make sure you run them properly. Yeah.
Is that the working you want us to see?
Yes. I do want to see your step. Right. To show your work on this, it looks like this. That's the minimum amount of work I'd like to see. Yeah.
So we can't just hit second calc and then find zero?
Absolutely not. In other words, this is how I tell that you're not doing that.
Okay.
I want to say there should be some differences here. And don't just make up decimal numbers, I will know the difference. Trust me. Next. About 7 minutes. I can do any type of problem you like. Optimization. Okay, would you like 2 pens next to each other or 1 pen by a fence? I'm not telling you.
2 pens next.
2 pens next to each other.
I like 50/50s.
All right. So you've got 2 pens, and I would like to maximize the area. All you know about the pens is that they're rectangular. They're adjacent, that means they're next to each other. And the total amount of fence you're using is 1,000 feet. The rest is up to you. Go for it. Let me grab my water. Talk me through this. Go, Lynn. Mm-hmm. Whenever you're dealing with anything in real life, draw a diagram. It should look like 2 rectangles sharing a side. Oh, and I should say they were also congruent. Same size. Sam, take over.
So the 4x plus 3y,
What are you doing?
labeling the sides.
Ah, good. Individual. You can label these anything you want. I like doing X's left to right. Just remember that the height is not the same as the width, so you gotta use different letters for that. Some people choose to use X as being the entire bottom. Does it work? Yes, it does. It's a little bit more annoying math, but it does work. You could do 2x plus 3y and it would work. Your value of X would be bigger than everybody else's. Try this. So go for it. Sam, go ahead.
So 4x plus 3y equals 1x.
Right, that's the total fence. 4 x's plus the 3 y's is 1,000. So that's a perimeter more or less. What else do you need to find? Nate, save us. What do you do next?
Area.
Area. What's the area formula?
It's gonna be used to XY or,
You tell me. I want the area of this whole thing.
so 2x, y.
2x times y. What is that?
Area.
Don't work too hard, but simplify.
Oh, 2xy.
2xy. What do you want to do with that area?
You want, find it. What do you ask?
What do you want to do with the area? What's the point of the problem?
Oh, maximize.
Maximize the area. How do you find a maximum area?
You take the derivative.
You have to take the derivative. There's a bit of a problem with taking the derivative right now. Rainey, what's the problem?
There's no exponent.
Well, that's true, which is annoying, but there's something that's actually stopping us from taking the derivative so far. Anybody see it? Go. There's too many variables. There are 3 variables. One on either side I can handle, but you take a derivative of the, yeah. So, cure for that? Yeah.
With the top formula, we set equal to y or x.
Right. Find x or find y, whichever you like best. And, I don't know, your preference?
Find y.
Find y, okay. So 3y is equal to negative 4x plus 1,000. And then y is equal to negative 4/3 x plus 1,000 over 3. What do you do with that? What's the whole point of that? Keep going.
Then you plug that into the area.
Yeah, I'm not saying it's gonna look pretty. It's actually gonna look pretty messy. The area is now equal to 2x times this mess. Negative 4/3 x plus 1,000 thirds. But what's the advantage of doing that, Austin?
So,
Why would you do that?
because then you can because now you can, distribute, take the derivative.
Try it. A equals what?
So A equals, you're gonna have negative 8 over 3x squared,
Correct.
plus 2,000 over 3x.
Very good. X. All right. And you'll notice there are only 2 types of variable in there. I mean, it got a lot messier than 2xy, I'll admit. But I don't have 3 variables anymore. So, Becca, take over. Take the derivative of this thing.
So it'd be
So A prime is equal to,
negative 16 over 3
very good,
x
over 3x plus
2,000 over 3.
2,000 over 3. Why did we do that?
And you could say equal to 0.
Set it equal to 0. That's how you find max's and mins. Go ahead and solve it for me. Why?
So subtract 2,000 over 3.
Subtract 2,000 over 3. Negative 16/3 x equals negative 2,000 over 3. Keep going.
And divide by negative 16 over 3.
Yeah, divide by negative 16/3. How do you divide by a fraction?
Multiply by reciprocal.
Yeah. So, Nate, take over.
You have to multiply by the reciprocal.
Okay, which is
3 over 16.
3 over
Negative 16.
3 over negative 16. The 3's cancel. I'm going to speed up because we're just about out of time. The negatives cancel. 2,000 over 16 is 1,000 over 8. 500 over 4. 250 over 2. 125. That's a total coincidence, by the way. So x equals 125. So this is 125, this is 125. How do you find y? Go. You've got a formula for y, right here. We've got y equals negative 4/3 times 125 plus 1,000 over 3. Let me just turbo that for you. So negative 500 over 3 plus 1,000 over 3 is 500 over 3. You might get a fraction as an answer. 500 over 3 feet by 125 feet is one pound. Good go. I will post this on YouTube as soon as humanly possible. Please stand. I'll post the other one too, again. I'll make sure it posts too. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. All right. See you all on Monday. Thank you very much.